Hello, good morning, and a very warm welcome I bid to Miss No. I, Manisha Kaur, would like to present this video here to you regarding the subject nature of science. Before moving further, I would also like to state that I have used the VideoScribe application here, which has enabled me to complete my task successfully. Now, without any further delay, I will begin my presentation. As you can see, today I am going to point out on three major aspects that we have to know when we are learning or teaching science. As you see on the slides, the first one is scientific theory, followed by scientific law, and finally the misconceptions on scientific theories. Do not worry, as we will go in detail for every aspect. Now, let's begin with the first one. What is a scientific theory? A scientific theory is a well-substantial explanation of some aspect of the natural world that is acquired through the scientific method and repeatedly tested and confirmed through observations and experiments. As you see, what I am explaining verbally here about scientific theory can be confusing and difficult to understand. Therefore, let's take a look at the slides. It explains how and why nature works. It is based on observations. How do we see and what do we see? Okay, but scientific theory has not been proven yet. Now, let's take a look at the examples. There are two examples here. The first one is the atomic theory. Atomic theory is the scientific theory of the nature of matter, which states that matter is composed of discrete units called atoms. Democritus was the first to suggest the existence of atoms, but only after 2 millennia, John Dalton's atomic theory came in hand and remains valid in modern chemical thought until today. The second example is the Big Bang theory. The Big Bang theory explains what happened at the very beginning of our universe. This theory was proposed by Georges Lemaitre in 1931. Now, let's take a look at the second aspect. It is definitely the scientific law. Scientific law is a statement based on repeated experimental observations that describe some aspects of the universe. The summarized version of it is on the slides. It describes what nature does under certain conditions. It is based on facts and can be observed. It has been proven true. It can be represented by mathematical equations. Repeated scientific experiments have been done to prove scientific laws, and it is also universal, means it can happen anywhere and at any time. There are also two examples stated for scientific law. The first one is Snell's law. It is also known as the law of refraction. It is a formula used to describe the relationship between the angle of incidence and refraction when light or other waves passes through a boundary between two different isotropic media. Isotropic media here would be the water, glass, or air. As you can see, the formula stated there is n1 sine theta 1 equals to n2 sine theta r, where n1 is the refractive index for medium 1, n2 is the refractive index for medium 2, theta 1 is the angle of incidence, and theta r is the angle of refraction. The second example is Ohm's law. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. There's also a constant in this law, which is known as the resistance. As you can see in the triangle shown here, it shows the relationship between V, I, and R. They are all interconnected, where V is the voltage or potential difference measured in volts, I is the current measured in ampere, and R is the resistance measured in ohm. The symbol for ohm can be drawn like that. Finally, the third aspect, which is the misconceptions on scientific theories. The first one, theories and laws are the same. People usually think that these two are the same, but after we have listed down the differences earlier, I think there wouldn't be a problem after this. The second one, there is a hierarchy between law and theory. As I've written below, people usually believe hypothesis comes first, and then theories, and then laws, which are false. The third, scientific theory is tentative and uncertain. And finally, theories are only guesses and not real, which are absolutely false. Now, let's take a look at a few similarities on scientific theory and scientific law. The first one, scientific theory and law are used for predictions. They are open for falsification. For example, Darwin's theory of evolution is now being falsified by many scientists. They are trying to get new evidence to prove his theory wrong. It is also supported by large empirical data. Now, let's recap. We have learned on the differences of scientific theory and scientific law with two examples each for both. If you have noticed, scientific law are supported by mathematical equations. This clearly differentiates it from scientific theory. We have also learned the misconceptions of scientific theories and the similarities between scientific theory and scientific law. That is all from me. Thank you.